Hi ladies and gentlemen, this is Mr. Green. This is another in my series of recordings on geometry. We are taking up Unit 3 and starting to work our way through Unit 3, okay? And so where are we at? We're looking at dilations and scale factors. What is a dilation? A dilation. I've heard this word before. We talked about it in first semester a little bit. This is what happens with your eyes when you go in to see the doctor, isn't it? You're in there, and the doctor looks in your eyes, and he puts these little drops in your eyes, and it makes that iris get really big, okay? And your iris gets really big, and he looks inside your eye, and he looks deep into your eye to see if he can't see your brain back there. No, he's just looking at the back of your eye. Don't worry about that. He's just looking inside your eye to see if everything's okay. But that's a form of a dilation. A dilation means I'm going to take an object and I'm going to make it get bigger. Okay? So we're just going to look at two-dimensional objects here getting bigger. Right? If it got a little bit bigger, that is a dilation. Or what if it wanted to get smaller? Okay? So it's going to get smaller this way. Okay? So, you know what? The best example here is Alice in Wonderland. She had the green pill and she had the red pill. She had to choose between them to see which one she would do. She get bigger or she get smaller. She took them both, didn't she? She dilated. She dilated in both directions. That's what we're talking about here. But in geometry, we have a very specific way of doing it. Okay? If I've got a object like this red object over here, this is my pre-image, meaning it starts before we do anything else. Okay? And I'm going to take this pre-image and I want to dilate it. And it's on a coordinate grid like this. They're going to give me a center of dilation. In this case, they're telling me the center of dilation is going to be the origin right there, 0, 0, 0. If I take a line and I draw it through that origin like this, see how it goes to that point over there? And if I take it this other point and I draw through that origin going this way, see how it hit that point right over there? I could do this for every single point on the original object and draw a line through the origin, and I would get the location of the dilated object. Well, that one didn't do too well. Sorry about that. Go off your iPad little drawing thing that you're doing here, and it just doesn't work all that well. Try again now. Okay, going from D through the origin this way. Yep. Come on down here. Just not big enough iPad. I can't get there. Okay, so we're just going to delete that one. But you get the idea. Okay, you go. I was going through the origin here. Do all dilations go through the origin? Not necessarily, but it's one way of finding them. Okay. How do we determine if we've found the spot? Well, you know what? What we're looking for here is some sort of a scale factor, some sort of a factor that they get us. If we dilate something, we should be able to take one length of the side here, and when I draw these lines, find a length in here that would be equal to that scale factor. So in this particular situation, my scale factor was greater than 1. Why? Because it went from here to here. It got bigger. It was greater than 1. Cool? Okay, looking at this object here, we're scaling from this red one to this blue one down here. So my point A was at 3, 5. 1, 2, 3, 5. Right here, point A. I drew a line through the origin. My point B is going to be on that line somewhere. They're telling me my scale factor is negative 1.5. What's the negative sign telling me? It means it goes through the origin. It's on the other side of in the other coordinates over here. If it was a 1.5 and it was positive, it would have been out here. It would have gotten bigger this way. Okay? So this one going through the origin tells me it goes negative down here. We went through the origin, so we're going to have to go negative in that situation. So I took the 3.5. I multiplied it times the 0.35. I multiplied it times 1.5. 3 times 1.5 gives me negative 4.5. 5 times 1.5 gives me negative 7.5. Guess what? I know where my new point's going to be. It's on that line and it's right there. And my point right there is at negative 4.5, negative 7.5. Easy to do. Since I know all the points on A, B, C, and D, I can multiply both the x and the y times that scale factor, and I'll find the new x and y coordinates for each one of them. I can plot the points and do it that way. So two ways of doing dilations. One, by drawing lines. Two, by looking at the points and finding the points based upon the scale factor. But what if you don't know the scale factor, Mr. Green? Well, in that case, they're probably going to give you the original image and another and the image that they're looking for. The original image called the pre-image, and the image that they scaled out here. So then you can take any 2 points on here, like C to D here, and you can find its distance. Well, how could I find the distance from C to D? Pythagorean theorem. Okay? We can take this higher one, it goes up half a unit there. It goes over 2, right? Or it looks like 1.5. Anyway, you can find those distances there using the Pythagorean theorem, and that's going to turn out to be a distance of 1.66 centimeters. You do the same thing on this image that we scaled it up from here, from C to D, and this one looks like it is what, 1, 2, 3, 3 units over and 1 unit up. So 3 by 1 gives you a distance of 3.3332 centimeters. If you divide those two things in half, the image divided by the pre-image, the new one divided by the old one, new divided by old, image divided by pre-image, the distance on one side give you a scale factor of 2. Would it work for the other sides? Absolutely, it'll work for the other sides. Would I be able to take the points here and then say, well, C is located at 1, 2, 3, 4, 2. 4, 2 times 2, let's see here, 4 times 2 would be 8. 2 times 2 would be 4. 1, 2, 3, 4, 8, 4. It still worked. I could take that and multiply it out. Yes, you can take one of these points, and if you know 2 points, you can do the same sort of thing. You didn't have to use the distance on the sides, but distance might help you if you're given the distances. Okay? Hopefully you're going to be able to figure these out. If you have any problems with them, bring them to tutoring on Tuesday or Wednesday or Thursday, and we will talk about them. Okay? I do appreciate the fact that when you are sending me K-mails, sending me things, you do tell me that you're in geometry. It helps me find you. It helps if you tell me what section of the geometry course you're in, because I do have multiple sections, and I can get your answer to you a lot quicker. I do appreciate it, and I look to talk to you next time.